India is just making its mark in the space industry one after another. After the successful mission of Chandrayaan-3, India's Aditya-L1 has done something crazy, and take a look at this. Aditya-L1 has taken stunning fast light images of the Sun. The Aditya-L1 mission is still in its early stages, but it has already made some significant contribution to solar research. In the coming years, the mission will continue to collect valuable data on the Sun's activity, helping us to better understand the complex and fascinating star. The first light images captured by Aditya-L1 are particularly exciting because they offer a new perspective on the Sun. These images were taken in the ultraviolet range of electromagnetic spectrum, which is invincible to the human eye. This allows scientists to see features on the Sun that are not visible in visible light, such as coronal loops and prominences. So what are coronal loops? You might have seen the images of the Sun where the lava is spitting out from its surface. These regions are called solar corona. And an interesting thing is, if you place the image of Earth in this place, it will look like this. And it might go reaching millions of degrees, while the solar surface or photosphere is significantly cooler than this. Coronal loops are arcing structures of hot ionized gas, we can also call it as plasma, that are confined to the Sun's corona by magnetic fields. Magnetic fields emerging from the solar surface trap and guide the hot plasma along their paths, forming these loops-like structure. Coronal loops are extremely hot, with temperatures ranging from 1 to 3 million degrees Celsius. They primarily emit light in extreme ultraviolet rays and X-ray portions of electromagnetic spectrum. These loops are often associated with regions of increased magnetic activity on solar surface, such as sunspots. The Aditya-L1 mission is still in its early stages, but it has already made significant contributions. In the coming years, the mission will continue to collect valuable data on the Sun's activity, helping us to better understand about the solar activity. Aditya-L1's instruments will allow scientists to map the Sun's magnetic field in unprecedented detail. This information can help us understand how the Sun's magnetic field drives solar activity, such as solar flares and coronal mass ejections. And this data will be used to address some of the most pressing questions in solar physics, such as the origin of solar wind and causes of solar flares.
If you're still here, please don't forget to like and subscribe to our channel.